Okay, we are on. Let me lower the volume. I think I was way too loud before. All right, let's try this again. We are on section 7.3, and we're going to do similar triangles. You say, I thought this was what we did the other day. No, it's not. The other one was similar polygons, which worked for, all kinds of different figures. We said that all the corresponding angles had to be equal to each other, and all the corresponding sides had to be in proportion in order to have a similar polygon. We're going to do a couple little shortcuts today and just talk about similar triangles. Now remember, we had to show two things. Do you remember me writing down that 1 and 2, and I said all the corresponding angles had to be equal or congruent, and then we said that the corresponding sides had to be in proportion. Let's write that out real quick, okay? So we had to say that all that stuff was true in order to say that those two things were similar to each other. Well, when you're dealing with triangles, you don't have to show quite as much stuff in order to say that these triangles are similar to each other. Now, without going through any proof or anything like that, and I don't think you'll really mind, to tell you the truth, but here's what this, we have a theorem, actually. Actually, it's called a postulate. It's not a theorem. So this one cannot be proven anyway. So there is no proof on this. That's why I wasn't going to prove it, I guess. This is a postulate, which means it cannot be proven, and this is just something that's accepted as fact. So here it is. Watch this. If I just had, now remember what we had to show before. I had to show 6 things. I had to show 3 angles equal to 3 angles, and then I had to show that all 3 ratios, right, of the corresponding sides were all equal to each other. That was 6 different things I had to show in order to say that my triangles were similar to each other. Well, this is a little bit shorter now. All I have to do now is only show 2 things. If I can only show that one angle of one triangle equals one angle of another triangle, and if I can show a second angle, like this one is equal to this one, that alone, that's all I have to show in order to say that this triangle is similar to this triangle. That's it. That's all I have to show. I don't have to say anything about the sides being in proportion. Okay, even though that they are in proportion if they're similar, I don't have to show that they're in proportion in order to say that these triangles are similar. So that's kind of cool. Look at this. Here's something we've talked about before. If these 2 angles equal these 2 angles, what must be true about the third? Because look, if I took these 2 and added them up, I would get the same exact number if I added these 2 up. How would I find that third angle? Well, what I would do is I would take these 2, add them up, and take them away from 180. But remember what I said? If I add these 2 up and I add these 2 up, it's going to be the same thing. If I take the same number away from 180, right? Take these 2 away from 180, take these 2 away from 180, guess what's going to be true? Well, my third angle is going to be equal as well. Right? So that's automatic. We've learned that before. We actually knew that before today. You might have not remembered it, but we learned it. If 2 angles of one triangle equal 2 angles of another triangle, then the third angles have to be equal to each other. So we really don't even care about that third. Let me see if I can get rid of those. I don't even care about that third angle, to tell you the truth. All I care about are the 2. If 2 angles of one triangle equal 2 angles of another triangle, then these 2 triangles are similar to each other. I'll put a big old squiggly here. This triangle is similar to this. So here's a question they're going to ask you to do. Let's get rid of this stuff. Here's something they're going to ask you. They're going to ask you to write a similarity statement. And we've done that before. We did it on section 7 too. That shouldn't be a big deal. Let's write a similarity statement now that we know that these triangles are similar to each other. So our similarity statement would be this. I could name this triangle anything I wanted as far as these 3 letters are concerned. I could name it ABC, BCA, CBA, ACB. It doesn't matter. Let's just call it triangle ABC. So here's my similarity statement. Let me write that down. Similarity statement. Because that's going to be a question on a quiz or a test, or both. Okay, they're going to say, write the similarity statement. So this triangle is similar to this triangle. So what is the statement? The statement is triangle, let's call it ABC. So we'll call this triangle ABC is similar to this triangle. Now, we got to keep it in the same order, though. I can't just take these 3 letters in any random order. Look, I went ABC. what did I go? I went 1 arc to no arcs to 2 arcs. 1 to 0 to 2. Let's do the same thing over here. 1 to 0 to 2. So what does my letters have to be? D, E, F. Now I made this really simple. Kind of kept it the same order of the alphabet. I didn't flip it around and twist it and rotate it and all that good stuff. So this one was pretty easy to see. But you realize what you're going to have to do. You're going to have, you're going to take one. It's going to flip. It's going to, rotate. It's going to do all kinds of stuff. And you're going to have to know which one goes with what. What side of this triangle goes with what side of this triangle. Okay? Which ones are the corresponding sides. And so what do? You look at the angles. All right? So that's my similarity statement. Now, if they wanted to, they could ask you this. They could say, write out the proportional sides. Write out all the sides and show the proportions of those sides. So let's do it. I don't even need the triangles anymore. All I need is this similarity statement. Remember what we said in the other lesson? This is super, super important. Let's write out all my sides and show that my sides are in proportion. Okay? So let's do this. Let's compare AB to what over here? Well, I use the first two. So what do I use over here? The first two, which is DE. Right? So that, if I compare those sides, what's it going to equal? Let's do a couple other sides. Let's go BC. Right? BC to what over here? Well, EF, right? BC is the second and the third. This is second and the third, so I put those together. And then what's left? I did AB, I did BC. What's left? AC is. So I compare AC to what over here? Well, it's the first one and the third one. So what's the first one and the third one over here? It's D and F. So that's D and F. So that right there would be my proportions. All right, those are all the ratios. They all equal each other. So that's my proportionality statement, I guess, if I want to get real technical with that. So what does that mean? That means, look, AB, if I compare AB, that's going to correspond to DE. See it? See how they match up with each other? Look, they're both opposite the angle with two arcs, aren't they? Look, BC and EF. BC is this one right here on the right, and EF is this one here on the right. What is it opposite? It's opposite the angle with one arc, and so is this one over here. So they match up. Does it mean that they're equal to each other? Absolutely not. This one's a lot bigger than this one, okay? But they do correspond to each other. Look at the last one, AC and DF. AC is opposite the angle with no arc. What's opposite? What side is opposite the angle with no arc over here? Well, DF is. See? It's opposite the angle with no arc here. So AC and DF go together. But you didn't even need the triangle to begin with. You could have just started off with that similarity statement, and you could very easily see that that's true. All right, let's do a quick little example here, and then we'll move on. Oh, by the way, I almost forgot something real big time here. We have a name for this. Remember, we said it's a postulate. We call this the angle-angle similarity. Did I spell that right? Similarity. Yep. Similarity and then postulate. I'll just shorthand it. Put P-O-S-T. All right. That is the name of this theorem right here that says that if two angles of one triangle equal two angles of another triangle, those two triangles are similar to each other. We call it the angle-angle similarity postulate. I had a book that I used to teach out of. They would call it the angle-angle-angle, all three of them. But really, if I know two are equal to two, I know the third one's going to equal. I don't even have to put that in my little name for this. I can just call it angle-angle similarity. I hope that makes sense to you. Let's do a quick little example, okay? All right, let's take a look at this one. This says determine if these triangles are similar to each other. So how do we know about, what do we know about triangles as far as being similar to each other? Well, we know that if, we just figured out angle-angle similarity postulate. So let's see. If I know that two angles of one triangle equals two angles of another triangle, then I know that they are similar to each other. Well, look. I got a 57 here and I got a 57 here. All right, that's good. So I got one angle that's equal to one angle. That's not enough. We need two. What about the other one? This is 48 and this is 75. At first glance, it may look like, oh, nope, these are not similar because look, even though that's equal, these two are not equal. Well, what are we missing? We're missing this one and this one. Let's just see what this angle is right here. So how do we do that? We take 180, or we add those two up and take it away from 180. Or you can just go 180 minus 57, I'm doing it on a calculator right now, minus 48. And that equals 75. How about that? Look at that right there. So that's 75 degrees. Now look at it. I got a 57 and a 57, and guess what else I have? I got a 75 and a 75. I don't have to bother figuring out this one. I could real easy though, because look, if I had a 57 and a 75, what's the other angle? It's 48, right? Just try it. Add those up, take them away from 180, and you get 48 right there. So now, are these two triangles similar to each other? Yes, they are. What's my reason? It says give a reason. It's simple. It's angle, angle, similarity. Don't just put angle, angle postulate. Put angle, angle, similarity postulate. Okay? And that's your reason. That's your reason why these two triangles are similar to each other. Now, they could ask you, let's see. Yep, it says, if it is similar, write a similarity statement. So, we got to write a similarity statement. We've done this several times already. I told you we'd have to. So, let's make sure that we know how to do that. Let's go green. Let's call this triangle anything we want. Triangle, I don't know, JLK. JLK is similar to triangle. Now, what do we have to call this one? Now, it's very important we put the stuff in the right order. If I went JLK, what am I going to have to go over here? Well, look at my angles. I went 48, 57, 75. So I started off with 48. So where's 48 down here? It's there. So what's my first letter? It's Q. Okay, so I went 48, then I went to 57, which is L. So what's L, or what's 57 over here? It's M. Of course, what's the last one? It's the 75 and the 75. That would be P. There it is. That's my similarity statement right there. So yes, the triangles are similar, and these are the triangles that are similar, and they're in the correct order. Notice the J and the Q are equal to each other. J is 48, Q is 48. The L and the M are equal to each other. L is 57, and M is 57. K and P are equal to each other. K is 75, and P is 75. That's my similarity statement. Make sure it's in the right order. They could... I don't think they ask you on this particular one, but there's other problems. Let's just do this for fun, okay? Let's just figure out our sides and the proportions of our sides. I think they say, trying to find where the question says, write the proportions, because I want to know how it's worded. I'm looking. Don't go crazy on me while I'm looking. Sufficient. I don't really see where they say it, but I've seen it somewhere. I just can't see it right now, so I'm not going to waste any more time with that like I already have. Let's just write out our proportions. Let's do it real quick. We did it before. JL to what? QM. And then what? LK to over here MP, and then what else? JK to, right, first and third one, QP. All right, so those are my proportions. Those are my proportions I have to set up. So there you go. That's the kind of stuff that they're going to ask you to do. Let's do another example. I'm actually not going to do another example. I almost forgot about this. Here's another situation. Look at this. I don't know anything about the angles. They didn't tell me that any of these angles were equal. I have no clue. Okay, but I do know the lengths of these sides. So what I'm going to do, what I'm going to do is this. I'm going to look at the corresponding sides. Look at this side. This is 12 and 6. Or they actually, yeah, let's just do it this way. I probably didn't do it the best way. I was trying to make it easier for you. But let's see this. Let's compare 12 and 6 to each other. Watch. If I compare 12 to 6, what's that equal to? Well, if I reduce it, it's 2 to 1. All right. Let's do 16 and compare it to this side that it's matching up with. So 16 to 8. Watch. Oops. 16 to 8. What does that reduce to? That reduces to 2 to 1. How about that? That reduces to 2 to 1. That reduces to 2 to 1. What do you think? Look at this bottom one. I'm going to compare 14 to 7 because they're both on the bottom. So I'm going to compare 14 to 7. What does that reduce to? That was crazy, wasn't it? Reduces to 2 to 1. All right, so Look, they all have the same scale factor. So what does that mean? That means they're all in proportion. All three sides are in proportion. Doesn't mean they're equal to each other. It doesn't mean this and this are equal. This one and this one are equal, or this one and this one are equal. That's not what it means. It means, though, that if I compare the left side of this triangle to the left side of this one, you get the scale factor of 2 to 1. I compare the right one to the right one, I get the scale factor of 2 to 1. I compare the bottom to the bottom, guess what? I get the scale factor of 2 to 1. They all have the same scale factor. So the sides, all three of the sides, have the same scale factor, which means all three sides are in proportion. That's the phrase that we use when we say that the sides have the same equal ratios or the same scale factor. It all kind of means the same thing. So when all of them are equal, when they all reduce to 2 over 1, it means that all of those sides are in proportion. If all three sides are in proportion, if one side and another side and another side, if they're all in proportion, not equal to each other, get straight on this, they're not equal, but if they're in proportion, then these two triangles are, guess what? They would be similar to each other. We don't call it just side, side, side. We call it the side, side, side similarity. Now this one is a theorem. It can be proven, and it's actually proven on page 475. I'm not going to do it for you, but it's there if you want to see it. So similarity. Okay, there we go. Side, side, side similarity. So if you know that the corresponding sides are all similar to each other, if they're in the same proportion, let's say it that way, if this side and this side have the same ratio as this one to this one and this one to this one, that means they're in proportion, and if they're in proportion, that means the triangles are similar, and we call it the side, side, side similarity. Okay, got one more to do, and then we'll do, I think, an example, and then we'll pretty much be done. Alright, I hope you don't mind, but I'm going to backtrack on this one a little bit. I'm sorry about that, because I just didn't feel good about putting the numbers there, because you didn't really know that this side was corresponding to this side, and you may not even knew the difference, but it bothered me a little bit. So let's think of it this way. If it was given, if they told us, okay, some things, if they told us that, let's say, JL, if I compare JL to MQ, alright, if I compared this one to this one, and that equaled JK to MP, right, this one to this one, and if they told you that LK compared to QP, if they told me that all three of those things were equal to each other, these three ratios were equal, then, alright, if all that stuff was true, then I could say that they were similar triangles. Putting the numbers there I thought was going to help, but I don't know if I was really doing it the best way I could. Anyway, if they told you that this and this were, the ratio of this one and this one was equal to the ratio of this to this, and the bottom to the bottom, right? Left to left, right to right, bottom to bottom. If all that stuff was true, then, guess what? Then the triangles are similar. So we'll call it triangle, what, JLK? Was similar. If I went JLK, then I have to go MQP. Alright, so that might have not made much difference to you, but I feel a little bit better about doing that because that's going to help us with the next thing. So let's go on to the next thing. Alright, let's take a look at this. I believe this is one of the last things that they give you on this. Okay, so, and we'll do an example after this. We'll try to wrap it all up. Now, here's what they give you. Alright, now we don't know anything about this. Just looking at the triangles. We can't really assume anything at all. But here's what they give you. They give you that if I took SR and I compared it to YX, that's going to equal ST compared to YZ. Alright? So if I compare, watch, I'm going to do this. Now this makes me a little nervous doing this, but watch. If I compare this one to this one, notice how I made that tick mark bigger than this one. They're not equal to each other, okay? SR, I'm not saying is equal to YX at all. I'm saying, but if I compare these two to each other, okay, they're the corresponding ones because they both have one tick mark. This one's bigger than this one, though, okay? That means this side is bigger than this side. Is that all right? ST, watch, I'm going to make two big old tick marks right here. And then I compare it to YZ. Doesn't mean they're equal to each other just because they both have two tick marks. This one's bigger than this. So it just means that they are corresponding to each other. They match up with each other. Now, if that's all I knew, if that's the only thing that I knew about these two triangles, I couldn't say anything about them. I could not say that they are similar to each other. But if they show me one more thing, now if they showed me that RT had compared to XZ was equal to all these, then they would be similar because of what we just finished talking about, which was the side similarity theorem. But that's not what we're dealing with. What they do is they give you one more thing. They give you one angle, not two. They just give you one angle. They say that angle S is equal to, right, angle Y. So if this angle is equal to this one, look, and it's between the two proportional sides. Do you see it? So between these two sides, that's where the angle is. It's not down here, it's not over here, it's between the two sides that I said were in proportion. Okay, the two pairs of sides that were in proportion. So what do I have? I got a side, I've got an angle, and I've got a side. Okay, let's see. It's given that angle S is equal to angle Y. All right, so let's write that down right there. So if this is all given right here, I've got two sides, or two pairs of corresponding sides that have the same ratio. It's a little wordy, but I got the comparison of these two sides to these two sides, and they're equal to each other. And if I know that angle S is equal to angle Y, which is the angle that's between the two, if I know all that stuff, guess what I know about the triangles? I know that the triangles are similar to each other. Let's write down our similarity statement. Triangle, let's call it SRT. SRT is similar to triangle. If I go SRT, look where I'm going. I'm going, let's see what angles is opposite. Opposite the no mark, okay, and then opposite what? The 2, and opposite the 1. So what would this be? Opposite the no arc would be, how do I want to say? Oh, the no arc right here, which would be Y. And then, so if I went SRT, let's just do it like this, watch. SRT is what? YXZ. You see it? Because S and Y go together because they both have an angle equal to each other. R and X go together because look, R is opposite the two arcs, or yeah, the two tick marks, and X is opposite the two tick marks right there. T and Z go together. Why is that? Because T is opposite the one tick mark and Z is opposite the one tick mark. So you can see why they would be matching up like that. They would be corresponding to each other. That's my statement, my similarity statement. Remember that? So make sure you're able to do that every single time. All right, enough of that. Let's have some fun and do an example, and that wraps all this stuff together. All right, bet you can't wait. Here we go. By the way, before we have all our fun, I forgot to name this thing. Okay, I named all the other ones. Remember the first one was angle-angle similarity. The second one was side-side-side similarity. What do you think this is? Side what? Angle, side. So we call this the side-angle-side similarity. All right. So there you go. Side-angle-side similarity. I want to make sure we name that thing because they do in the book, and it's kind of nice to be able to refer to it. Okay, now we'll do the examples. Sorry. All right, we're going to do two examples. This is the first one. What they ask you to do here is to just determine whether these two triangles are similar, and if so, write a similarity statement. So here's the two triangles they're talking about. They're talking about this little triangle right here and this big triangle right here, and you have to determine, are they similar to each other? Well, let's think about this. The easiest way to prove to show that two triangles are similar would be to show that if two angles of one triangle equal two angles of another. So let's go for that. What do you think? Well, the only thing I know about the angles, though, here's a little problem. That's the only thing I know right there, that those two vertical angles are equal to each other. I can't say that this and this are equal, that P and S are equal. A lot of people would say, oh yeah, you could because they're alternate interior angles. But we don't know that this side and this side are parallel, so we can't use any of that stuff. We can't say that Q is equal to T because of alternate interior, because we don't know that they're parallel. It's the only thing we know about the angles. So what we're going to have to do is we're going to have to figure out something about the sides, right? And we're going to have to see what the ratio of the sides are. And really, maybe we can just do the side angle side, because look, this could help us. So let's try that. Remember, let's try to show that this side is in proportion, or I'm sorry, the ratio of the sides are equal to each other. Let's see, what can we do? We could do this. Actually, we could do all three of them. Let me see what the best way to do is. right, let's see what we can do here. I don't think my explanation here is going to be the greatest in the world, but I think it'll make a little sense. Let's take a look at 8. Let's just start. You got to start somewhere. Let's start with this one. What do you think this relates to? Do you think this goes with this side right here? Do you think it goes with the bottom one? Do you think it goes with the 20 right here? Not really sure, but let's just try it. Let's go 8 to 20. All right, 8 to 20. We always reduce this stuff to see what our scale factor is. So 4 goes into this twice. 4 goes into this 5 times. So that would be a scale factor, right? 8 to 20. Let's see if the other ones reduce down to 2 to 5. If they do, then we know we picked our right sides to pick to see what's in proportion. Let's do let's forget the decimal. Let's do this one right here. Well, we'll do that in a second, but let's just do this one. Let's go 6 to 15. Let's see what we get there. 6 to 15. We've got to reduce that. 3 goes into that twice. 3 goes into that 5 times. Wow. There we go. We got two sides that are in proportion. That's cool. So I've got 8 and 20. They have a ratio of 2 to 5. 6 and 15 have a ratio of 2 to 5. What about this one? 5 to 12.5. Now that's a little ugly, but let's try it anyway. Let's go 5 to 12.5. Let's see what goes into these. See the best way to do this. I guess we could just use the decimal. Let's just do the division. Let's go 5 divided by 12.5, and that comes out to 0.4. Alright, so let's forget this little fraction bar right here. Let's just make it equal to 0.4. And you say, well, wait a minute. Is 0.4 equal to 2/5? Well, what's 0.4? 0.4 is the same as 4/10, isn't it? Okay, and if I take 4/10 and reduce that down, yeah, that's 2/5. Check it out. So what looked kind of crazy actually does reduce to 2/5. I hope you understand that. 0.4, right? I just did this in a calculator to get from here to here, and I got 0.4. 0.4 is the same as 4/10. You should know that from your fraction days. Then you reduce 4 over 10, which is 2 to 5. Check it out, all 3. So is this triangle similar to this? Absolutely, it is, and they all have the same scale factor of 2 to 5. So that's kind of cool. So now let's do some marks here. Remember, this one went with this one, right? This one's a little bit bigger than this. Okay, remember, they're not equal to each other. This top one went with this bottom one, okay, and then this third one, we'll go little, and we'll go to this third one. All right, remember, they're not equal. I'm just doing that to show you what sides match up with what. So if I wanted to write a similarity statement, what would I call this? I could call this anything. Let's go PQR. So triangle, it's supposed to be triangle, it's ugly. PQR is similar. Now here's the part I got to make sure I match up correctly. Which one matches up with the P? Look at the P. Well, it's opposite the 3 arc. What's opposite the 3 arc here? Or the 3 tick marks, I should say. The S is, so the P and the S go together. Which one goes with the Q? Well, Q is opposite the side with 1 tick mark. So look over here, 1 tick mark, opposite T. So the T goes together. So I've got ST. Well, the only other option is R. There it is. That's my similarity statement. I hope that makes sense to you. Let's do another example. Alright, look at this crazy thing. Looks so scary, doesn't it? What it says is to solve. Basically solve for your variables. What are your variables? X and Y. So I got to find what X and Y is equal to. You think, what in the world's going on here? How can I do this? Well, let me show you something that I did. Sometimes these are overlapping triangles because I got 2 triangles here. If you don't see it, see, I got this whole big triangle right here. Don't you see it? ACD. And then I got this little triangle here too. I got ABE. You see it? I got the little triangle. I got the whole big triangle. This thing right here is not a triangle, but I got 2 triangles right here. Sometimes, and it's overlapping because see that little triangle's inside the big triangle. Sometimes a lot of people don't mind working with it like this, but there's a lot of times people like to separate them. That's what I'm going to show you. I just went through a little work right now, and I took this, I copied it, and I took the big one and I copied it in there. What I've done is I separated them into 2 different triangles. Alright, so let's see if that helps at all. I think it might. But we're going to have to label some stuff. So let's label some stuff. Let's look at the little triangle first of all. Let's label all the sides. we'll just do the letters, okay? Forget the A, B, C, and all that kind of stuff. So this side right here is the x, so that would be this one right here. Hopefully you see that one, okay? The y is the bottom of it, so that's the y. And then the 3 is this side, so that's a 3, right? Good deal. Let's take a look at the big one, right? Let's look at the right side, this side right here. Come up here on the big triangle, what's the right side? Well, it's 3.5, so that's 3.5. Let's look at this side right here. Okay, which one matches up with that one? It's this one here. It's the whole entire thing. It's not 3. It's not this little bit, which would be 2. It's the whole thing, which would be 5. So I'll put a 5 here. What about the bottom, though? Look at this. This little bit's y, but this little bit's 3. Does that mean the bottom of this is 3? Nah, it's the whole thing, from A all the way to D. A lot of people say it's 3y. It's not 3y. What do you do to the y and the 3? You add them up. So it's y plus 3. So the bottom is y plus 3. I hope that makes a little bit of sense to you. I don't know. Well, what do we know about these triangles? Do we know that they're similar? They don't tell you that they're similar. You have to figure it out on your own. So what I'm going to do, let's do this different color. What I'm going to do is this. Look to see that one of the best theorems you can use on this stuff, it's actually a postulate, is the angle-angle. Look, see the whole big triangle and see the little triangle? They both share that same angle, angle A right there. So that's one angle. There's something else that you know. You know these are two parallel lines. Why in the world would they give you parallel lines on this triangle like that? Well, because parallel lines cut by transversal, so guess what? This angle right here is equal to this angle right here. Look what I have. See, I've got this angle equal to this angle, because that's angle A, right? Because they overlap each other, sitting on top of each other. But I picked one up and moved it off to the side, and so now they're separated. But those two angles would equal each other. What's the other one? Right here. This one right here would equal this one right here. I hope you see that. I think I see it pretty good. Or you could have said that this angle here and this angle here are equal, but we don't really need that. If I know that two angles of one triangle equal two angles of another triangle, guess what I know about that whole thing? I know they're similar. If they're similar, the sides are in proportion. So let's set up a proportion. Before I start setting up my proportion, let's do the scale factor first. So look what I know. I know this is a 3. What does this match up with? Well, look, it's opposite the angle with two arcs. This is opposite the angle with two arcs. It's 5. So what's my scale factor? It's 3 to 5. That's really important. That's my scale factor. Remember, the other ratios of the sides have to equal 3 to 5. Look how easy this is. Watch. 3 to 5, I'll write it down, equals what? X to, what side matches up with x? Well, 3.5. So x over 3.5. So I can solve for x. Let's do it real quick. 5x equals 3.5 times 5, or times 3, sorry. So 3.5 times 3 is, well, let's try this again. 3.5 times 3 is 10.5, 10.5. So 10.5. Divide both sides by 5, and that should be 2.1. 2.1. So that's what x is. There you go. Set up a simple little ratio. Find the scale factor. 3 to 5 equals x to 3.5. See how they match up? Right? We could do the same thing with y. Look at this. Again, use the same scale factor. That's why I put it in a box, because it's so important. Use the same scale factor. 3 to 5. 3 to 5 equals what? Y to what? Y plus 3. See how I compared them? I went this left side to the left side equals the bottom to the bottom. There it goes. Left to left, bottom to bottom. And now we can cross multiply and solve. All right, let's do that. 5 times y is 5y equals, now remember we have to distribute it through this. I'll show every little step so you don't get lost. And now that's 5y equals, let's multiply this through, that's 3y plus 9. Subtract 3y from both sides. And so I get 2y equals 9, divide by 2, and that's my answer. Y equals 9 over 2. Or if you really wanted to write it, 4.5 or 4.5, I guess you could write that, but I would just leave it 9 over 2, to tell you the truth. It's just easier. You don't have to worry about making a mistake and turning it into a wrong fraction or a wrong decimal. Just keep it like that. And that's it. That's x and that's y. So I think when you have overlapping triangles, I think it's really easy to take this and separate them. It's a little extra work to draw it out, but it's not that big of a deal. I think it helps you out. I really think it makes it easier. So take this, make it small, or make it the same size, but just separate it from the rest of it. Take the whole big triangle, separate it without all those lines in the middle and all that kind of stuff. Then take a look to see what's equal. These two angles are equal to each other. This one and this one, okay, and these two, because of parallel lines, alternate interior. Actually, they're not alternate interior. I might have said that earlier, and I messed up. They're corresponding angles, okay? They're corresponding angles, so this angle equals this angle, and then you just do your proportions, and you're good to go. All right. If you didn't catch that in class today, please go home and watch it on YouTube and slow it down. Take little steps. All right. Draw it out and do your best. All right. Let me give you a little homework assignment, and then we'll go over it when I'm back on Monday. Okay, I'm not going to give you a whole lot of problems like I normally do, but these problems, I want you to be careful with these, okay, and just do the very best that you can. We're doing just page 480, and we're going to go 16 to 21. All right, and this is section 7.3. All right, so make sure you do those from the book. Those are due on Monday. Have them ready for Monday, and we'll go over these on Monday together. All right, have a good weekend, guys. Bye.